Today's curiosity is assisted by Moon Tower Stout from Sucrum's Brewing in Winnipeg. They describe it as having heavy malt flavors, a roasted coffee-like aroma, and hints of rich dark chocolate. Yep, definitely getting all those out of that. That's excellent. So today, I'm going to be taking a closer look at this LED TV backlight tester that I got in the last mailbag. I played with it a little bit there and demonstrated that it, does what it says. Although I didn't test it with an LED TV backlight, and I don't actually have one conveniently available to test with this, but it can test pretty much any kind of LEDs. It's a neat idea. It basically puts a current limited voltage across whatever you're testing using these probes, and it can test voltages up to 300 volts, but it current limits to 20 milliamps. There is a second mode, apparently, that has 0 to 19 volts DC, and I'll see if I can figure that out. I think I found a video from Big Clive that took apart a similar unit, not exactly the same as this one, and he found how to use that 19 volt mode. I'm not convinced that it's all that reliable. In that mode anyway. When I've been experimenting with it, it will go into that mode, but after a few tests, it drops out of it and goes back to the 300. So you can't necessarily rely on it staying there. Although maybe that's just user error. I don't know. Regardless, there's not much information about it other than, like I said, a few videos. What it says on here is basically what you get. Automatically adjusts current, short circuit, constant current, double display of output voltage and current. That's one thing that this has that the one that Big Clive took apart, and most of the other ones, or a lot of the other ones, don't. This one gives you both a voltage and a current. It shows you what current it's testing at, typically 20 milliamps, but it does bump up to 50 milliamps after a little while. Unfortunately, there was no manual came with this thing, and while the website, the page on AliExpress where I bought it, does have a link to a manual, it's not all that useful. Let me show you. So here's the page that I bought it from on AliExpress, currently going for $21.79, which is pretty close to what I paid for it. And it does have a little bit of an explanation about it, but it's the usual poorly translated. Exquisite and compact. The voltage adapts automatically. Short circuit does not burn the lamp beads. Yeah. Other than that, there is this user manual here, which is pretty much useless. It's exactly the same as the stuff that's buried in that poorly translated description. Use a test pen to touch the positive and negative ends of the light bulb or light panel to light up the light bulb. At the same time, the testing instrument will display voltage and current. The voltage of the same type of strip should be the same. Gee, really? If the voltage error is worse than 3 volts, then there may be a problem. And that's literally all there is to the attached manual. Looking at another listing, it had a slightly different manual, in quotation marks, but it's not that much different, and it's certainly not much more useful. And there are other variants on this. This one is closer to the one that Big Clive took apart, but they are fairly similar. The main difference from the outside is the one that I've got has a current display, so something inside has got to be driving that in addition to the voltage display. So let's just play with it a little bit. I'll plug that in off screen and turn it on, and you can see that it has an open circuit voltage of 306 volts. I wonder if that's really what it is. I suppose that's easy enough to test. Being careful not to touch it because it is, 297 volts. Not as perfectly calibrated as you like, but I guess that's within 10%. Something to keep in mind, I guess, when you're using it. But let's grab some LEDs to play with. Might as well just play with the high-powered ones. We know it'll do lower-powered, normal LEDs. Let's just do this one just for good measure, which is just a little blue LED. And yeah, that's about 3.3 volts at 20 milliamps. Pretty much what you would expect for a normal blue LED. Let's try with this higher wattage LED. I think this is a 5 watt, something like that. Comes in at about 8.3, 8.4 volts at, again, 20 milliamps. But being a higher power LED, the tester will step it up to 50 milliamps, and now it's showing 8.9 volts forward and is much brighter. And if you just take off and go back on again, it's at 20 milliamps for about 10 seconds before it steps up. There it is. So I guess that can be useful. What other LEDs? We've got these red, green, and blue ones. There's the blue, which is again going to be about 3.0 volts, 20 milliamps. The red's 1.8 volts, again with the same 20 milliamps. And the green is again pretty much 3 volts. Fairly standard LED stuff. These are a single LED. This one is multiple LEDs in series. This is a horrible little project that I had put together, attempting to make myself a ring light years and years and years ago. And that should show that it does multiple, in this case, 5 in series. So 5 3-volt LEDs in series, 3, 6, 9, 12, 15 volts. So yeah, about 13.7 volts. It's a little lower than I thought, but at 20 milliamps, sure. When it steps up, yeah, closer to 14.5 volts at 50 milliamps. Not the full brightness, because again, these are, I think, 1 watt LEDs. But you can also just check a single one anywhere on here to make sure that they are happy. So even though it starts at, oh, looks like I've got a bad LED in my string here. And that one's quite dim. Okay. But I think those ones, yeah, those ones are all happy. But that one and that one are not. So there you go. It can be used for troubleshooting, and that tells me that I've got 2 bad LEDs in my low budget ring light here, which quite honestly I used like 6, 7, 8 years ago, something like that, when I was using a camcorder rather than my phone. Anyway, so about this 0 to 19 volt range right now, and it defaults up to 300 volts as we can see, but to put it into the lower voltage range, what Clive discovered is you just hold that for a few seconds shorted until that starts flashing. Can you see? Yeah, it starts flashing those bars, and then release. And now it is in 19 volt mode. And that works exactly the same. 20 milliamps and 8 volts, because of course it doesn't need the higher voltage for these ones, right? And that should still step up to the higher voltage or the higher current. Oh, maybe it doesn't when it's in 19 volt mode. Okay. Interesting. Yeah, I know that's out of focus. My hands are busy. I can't change my focus. And then to put it back into 300 volt mode, just short it for a few seconds. It starts blinking and it's back there again. As I mentioned earlier, when I was just messing around experimenting with this thing and practicing a little bit before I started the video, after doing some testing, it would occasionally drop back into 300 volt mode. So if you have really, really sensitive things that take lower current, maybe that 19 volt isn't all that trustworthy. Anyway, let us get inside this thing and see if the circuitry is the same as what Big Clive found in his. And I will put the link to his video down below and at some point up in the corner here, in case you want to go and check it out, because he goes into a much more detailed circuit description. He does a full reverse engineer, which he said took him 3 days, so I don't feel like doing that. But I will see if this one is substantially different than his, and I'll give you just a rough block diagram kind of overview on this thing. So 4 screws, back comes off. We have a 1 amp fuse there, that's good. Anti-tracking slot there and underneath the transformer, that's good. Opto isolator there and another one there. This is looking very familiar. transformer isolation, and it talks like transformer isolation in the sale description, so that is true. That's good. What appears to be a Class Y capacitor over there. And yeah, it claims to be an X1 and Y1 class capacitor, so safety capacitor across there for interference purposes. That's good. Let's see what this little power supply chip is here. CS8222BO from Semic. That is not the same as the one that Big Clive had, even though the general circuit arrangement looks the same. Maybe it's similar pinout or cross-compatible. Let's see if we can find any information about that. The one that Big Clive had was a Bright Power constant current LED driver. This one is a Semic constant current LED driver. So I guess probably pin compatible, or at least compatible enough anyway. 500 milliamp current max. Uses 100 kilohertz PWM dimming. By the way, this is a machine translation from a Chinese website, so it's going to be a little bit wonky, but we give a little bit of information about it anyway. It's apparently a buck constant current, built-in MOSFET, 20 kilohertz PWM dimming. Didn't it say 100 kilohertz up here? Regardless, it is an LED drive chip that's being pressed into service as a general purpose power supply. Anyway, just looking at the rest of the board, we have one primary connection and two secondary connections on that transformer. Some diodes, capacitor over there, 15 microfarad 400 volt, which makes sense because we are generating up to 300 volts over here. What else? We got some diodes. What are you, transistor? No markings. Not useful. Although we can see that it is labeled as a transistor and not a diode, so I guess we know that much about it. And then over here we have another 8-pin chip, which is connected to some diodes, a transistor there, opto isolator. So I'm guessing that, in conjunction with this capacitor and this inductor, are probably taking the higher voltage and current limiting it down for the output, probably through that transistor there. And that chip is BP2866A, which I think is a Bright Power branded chip, which is going to be similar to what Big Clive found on his circuit. And that's another LED driver, which is, in this case, being used as a constant current source. Again, probably with this transistor over here doing the heavy lifting. Yeah, as suspected, it is an LED constant current driver chip. There is the basic application circuit. That's going to be our load. Whereas current sense is that resistor there on pin 7. And it is only a 7-pin chip. It's in the shape of an 8-pin chip, but it doesn't have one over here. So that's essentially what's going on inside there. Although this power supply section is much more complex than what's shown here, but it is still a DC power supply coming in to power the thing. And yeah, it can handle a wide range of input voltages, which makes perfect sense for this thing. And again, with 300 volts DC happening as its open circuit, that's not really all that surprising. And the rest of the magic is happening in this little IC down here, which I'm going to guess is a microcontroller. You can see that there are lines going to the LEDs for the display. The little guy beside it is a 3.3 volt regulator, no surprise there. Unfortunately, this chip has to remain a mystery. Dagnabbit. And this over here, as Big Clive found, was the transistor and resistor that switches in and out to switch between the 50 milliamp and 20 milliamp mode. That is under the control of the microcontroller over here. So similar to the one that Big Clive got, a different chip there, decent power supply, unusual way of getting to the power supply. Normally you would use a dedicated power supply chip rather than an LED driver, But I mean, it was designed for testing LEDs, so presumably it was originally created in a factory for factory testing LEDs or something like that. And the engineers there are used to using these LED driver chips, so they just went with it. Or at least that's a reasonable enough theory, I suppose. So let's toss this guy back together and see if it still works. There's no reason that it wouldn't, because I haven't actually done anything damaging to it. But other than that, I don't know that there's much else to say about it. It may be kind of lame for me leaning on Big Clive so much for the prior art, but like I said, he took a good 3 days to fully reverse engineer the circuit and draw out a circuit diagram. And this one is very close, minus the different chip and the ammeter display. So I do encourage you to go and watch his video. It's from about a year and a bit ago. You've probably already seen it anyway. I'm assuming that everybody who watches this channel also watches a lot of the other electronics channels, and his being one of the big ones, I'm sure you've probably seen it. Anyway, that is this thing. I think it is going to come in handy around here for testing LEDs and whatnot, especially if I get some unknown ones, or if I'm working on a circuit that has a nice long series string of LEDs in it. Like, for instance, this lamp that I worked on, oh god, what was this? This was a couple of years ago too. Let's just see what goes on in here. I'm pretty confident that if I do that, after first reconnecting the test leads, oops, turn that guy back on. Now let's try this. There we go. The whole thing lights up, yeah, all the way back behind me, just like I expected it to. If I can hold that on there for long enough, I should get the higher current mode. So 26 volts right now at 20 milliamps. And if I can hold it steady on there long enough, yeah, 26.7 volts at 50 milliamps. But more importantly, I could see that all of the LEDs lit up. So if I was diagnosing this thing, that would be a very quick indicator that the problem is not with the LEDs themselves, it is with the driver inside. And that was the original problem with this thing all these years ago. Anyway, that was, again, just a quick look at this thing. I'll put links down below to where I got it from if you're interested in it. And of course, a link to Big Clive's video, because he did the heavy lifting from my understanding of this thing, and I appreciate that. Thanks for watching. Questions or comments down below. I will talk to you later.